Hello guys, in today's lesson we will be talking about cache techniques. When we say cache, a cache is a small fast memory located closer to the CPU that stores frequently used data or instructions so that the processor can access them more quickly than from the main memory, which is the RAM. Okay. uh, so the cache techniques are a method used to improve the efficiency and the speed of a cache memory in the computer. So when we say cache, these are the techniques that I use here, that I use to ensure or to improve the efficiency of the or the speed of a cache in the computer. We we firstly talk about the fastness of a cache. So these techniques in like these techniques make sure they are these techniques are put in place. Let me put it in that way. They are put in place to improve the fastness of the cache to be able to frequently use data instructions so that the processor can access them quickly. Uh, these techniques help the cache to how will I say it, to help the cache to frequently frequently use them or use the data or instructions. So we will be talking about some of the techniques that are being used to to improve the efficiency and the speed of the cache memory in the computer. So first of all, we will be talking about the cache mapping techniques. This determines how the data from the main memory is placed in the cache. And another the cache mapping techniques, we have the direct mapping. The direct mapping, it shows how each block of main memory maps to exactly one cache line. When we say a block memory talks about when we say a block let's talk about the block memory. When we say a block memory, a block memory a block memory talks refers to a fixed chunk of data that can be transferred and to and from the cache. It is the basic unit of the memory that the cache works with, and it maps to the cache line. So this is this one, the definition of a block of main memory. It's a fixed size chunk of data that can be transferred to and from the cache. It is the basic unit of the basic unit of memory that cache works with, and it maps to the cache line. Okay. When we say a cache line, a cache line also refers to the smallest unit of data that can be transferred between main memory and the cache. It can also be called the cache block. So think of it like this: when a CPU requires data, it does not bring one bit to into the cache. Instead, it fetches a whole block of nearby data. That's this data. This block is called a cache line. Typically, a cache line is to a 32, 64 or 128 bytes long, depending on the CPU architecture. Why cache line? Okay, why cache line? If you are using a one memory address, you will likely to use the nearby address too. So instead of fetching just what you need now, it fetches a tag that include nearby data to save time. Yeah, to save time. So the direct mapping, so as we say, the direct mapping shows how each block or each block of main memory maps to exactly one cache. And we talk about the meaning of cache line, and we now know the definition of the how what refers to a block of main memory. The face size chunks of data that can be transferred to and from the cache. Yeah. So the direct mapping is fast and simple, but more conflict. It's more conflict. So the diagram below shows how the direct maps works. Each block of the main memory maps to one cache line, as we say. So these diagrams, this is the main memory and this is the cache, and we have a block offset. Yeah, a block offset. So this you see the main memory, this is the cache. This is the how do you call it, the block of main memory, and this is the cache line. So they are interacting there. The data is being transferred and transferred from and to the so, um, so let's go to the next this one, the next cache mapping techniques. We have the full associative mapping. A block of memory can go into any uh, yeah yeah a block of memory can go into any cache line. As we already talk about the cache line, any block of memory can go into any cache line. Yeah. So yeah, the full associative, sorry, let's correct this place. The full associative is flexible but slow to search. Slow. Where is flexible but works slow. Yeah, works is slow. Then we have set associative mapping. Cache is divided into sets. A memory block maps to any line within the set. The set associative is balance of speed and flexible. Yeah, flexible. When you say flexible, it's flexible. It has flexibility. Yeah? And it's balance of speed. Yeah. So this is the diagram. These diagrams, the diagram of the set associative is here. So the set associative mapping. A block of main memory can map to any cache line. Sorry. Can map to any cache line in a set. Yeah. So we also have other cache techniques. Which are not here in the slides, but we will talk about it. So we will talk about it now. We have the cache replacement policy. When the cache is full, this policy decides which data to remove. Under the cache replacement policy, we have the last recent use. It removes the last recent accessed block. And we also have the first in, first out. It removes the oldest block in cache. And we also have the random. It randomly remove a block. Okay. And we also have something which one of the techniques which is called rights policy. Say policy, sorry, rights policy, rights policy. Yeah, this determines how rights are handled between cache and the main memory. And under the rights policy, we have the right true. Data is written to both cache and memory. This is consistent but slow. And we have the write back. Data is being written to memory only when the block is removed from cache. It's fast but needs more control. Uh, needs more control. So this is all this is all we will talk about. We will be talking about the case techniques here. This is all we will be talking about. To conclude, to conclude, direct mapping simple block to line mapping, fast, purple, the fast, associative mapping, flexible block placement, low conflict, set associative, hybrid of above, balanced, and we have and so on and so on, and so on and so forth. Thank you.